This is my 23rd video in my Casting Shadows series where I'm going to talk about shading a sphere, and I'll discuss where to put the light area, the shade, and the shadow, but I'll also talk about colors, which are very important. And it's all in my art instruction course on Amazon. Let's start out in the dark with the sphere above the surface. When we add a light source, think of it as a cone of light dividing the sphere into the light area and the shade. The shade is also called the form or core shadow. The sphere blocks the light from reaching the surface, resulting in the cast shadow. Shadows for spheres are always circles or ellipses. A light ray grazing past the sphere touches it at 2 points, which we'll call the tangent points, and all this area is in shade. The middle of the cone of light hits the middle of the sphere and the center of the shadow, and is perpendicular to the terminator at this point. The position of the terminator and the relative amount of light and dark areas we see depends on our viewpoint. If we're looking at the light area, then the dark area is a sliver. If we're looking at the dark area, then the light area is a sliver. The terminator is the straightest when we look at the middle of the sphere. Always give it a bit of a curve so the sphere doesn't look flat. How can we identify the terminator? Due to its gradual change from light to dark, it's often difficult to find, especially with reflected light. You can see the terminator here, but the reflected light is lighter than the terminator. You could blur your vision so major values coalesce. You could posterize the image using a computer, but here the computer combined the shade with the halftones, so the terminator is higher than it really is. Alternatively, the terminator can be found where the shadow of the pen begins. The easiest way is to find the light rays that are tangent to the sphere and reach the edges of the cast shadow, and the central light ray is perpendicular to the middle of the terminator. So let's put this all together step by step. First, find where the light rays touch the sphere at a point. Then find the terminator that divides light from dark. Its ends must be at the tangent points, and its center would be the center of the circle. It should curve since it's on a round form, but how much it curves depends on our viewpoint. Estimate where you think the sphere touches the surface, which is a point vertically below the middle of the sphere. And the shadow touches this base. It can go like this or it can go like this, but it always goes through the base. This triangle says it all. The center of the circle goes to the base. The base is connected to the middle of the shadow, and the center of the shadow is hit by the central light ray that goes through the center of the circle. To finish this shaded sphere, we need to add the halftones. So here's the terminator, and the halftones are in front of the terminator and make the sphere look round. But drawing shadows is not just about the mechanics. You have to get the colors right too. So let's look at some examples. Here we have the terminator and 2 tangent light rays on either end. There's a central light ray here going through the middle of the sphere, and the shadow of the axis hits the base of the sphere. This is a late afternoon sun, and how do we know that? For one thing, the shadow is long, so the sun is low on the horizon. Also, the light has some orange in it, and how do we know that? Because the color of this orange floor is enhanced by the orange light. That is, the orange-tinted sunlight enhances the saturation of analogous colors, like orange or yellow. Here is the same ball seen from a different angle. This is backlighting with the evening sun in front of us. We see actually most of the terminator going around the ball, and it's composed of tangent points. A few of them I've shown here. And the tangent points are where the light just grazes by the terminator, so this whole back area becomes shaded because the terminator blocks light from reaching it. You can see that there's a little orange area here, and that's from light hitting the orange floor and then bouncing up to the ball and then to our eye. We can almost see the base of the ball at this angle. In this first ball, we see a line from the middle of the circle down to the base, which connects to the middle of the shadow. And here too, we see the line down to the base, which connects to the middle of the shadow here. Now this is the noontime sun, and we know that because the light area is extremely white, and the whitest sun is during noontime, and the shadow is very small. Now this is likely artificial light because you can see the white area isn't nearly as white as the noontime sun, and the grass is darker. This one is artificial top lighting because we see the little rectangular overhead light. We can tell the intensity of light by looking at the shading of the sphere. So these are high intensity lighting situations. You can see that the terminator is very sharp here. In this one, there's some reflected light down here and a bit of a highlight, which you can see only with high intensity light. And then with low intensity light, we don't see any clear terminator. The shadow is faint. We see a bit of one here, and we don't see reflected light. We know this is on an overcast day because the sky is gray, and this is in the shade because it's reflecting the blue sky behind it. Here again we have an evening sun, and although we don't see much of the shadow, we know it's an orange color or orange-yellow because it enhances the color of the red ball but reduces the saturation of the complementary green grass. The evening sun causes some yellow in the light area and some orange in the halftones, where the orange light grazes by the ball with some rays coming to our eye. And we see the texture best along the terminator. The shaded area in back is blue-gray, and that's reflected from the sky behind the ball. So shading a sphere will tell us the color and intensity of the light. The light area on the sphere tells us the color of the light. If it's tinged orange, then the light must have some orange in it. Colored light enhances analogous colors and dulls complementary colors. And intense light causes sharp terminators, sharp shadow edges, lots of reflected light, and sometimes highlights, which are reflections of the light source. So please remember to subscribe and check out my book, The Art Instruction Course, on Amazon.